and welcome to another RMA Fire tutorial. Today I want to show you guys some very interesting techniques on how we can go about doing some soft serve stuff and mixing that with with two other simulations. In this case, you can see that we're gonna have chips in there and we're gonna have some whatever chocolate or some other stuff on the top. So without further ado, let me show you guys the setup. For starters, something that I found that is pretty important on this kind of simulation is having a good collider. So we want to have a solid collider object. I'm gonna show you guys how I built this from scratch. So real quick, all you need to do is set up a tube. And by the way, if you guys already know how to set this from scratch, you can skip this part of the tutorial. Real quick, just drop down a transform, scale it up to whatever scale you need it to be, and let's have a look at the smooth wire shaded so that we can see that we want to have more subdivisions in there. Now if you hit space and number 3 on your keyboard and then drop down a bend, I used the bend so that I could basically just control my tapering like this and squishing this so that I could get some cool sort of cup or a nice container, because if you sim this on a flat plane, then you're never gonna get the results that we want. Last, I did an extrude, and on the extrude we want to have some depth to it with the output back so that we can have a clean shape, and that is exactly what I built here. We have this interesting collision. Now you're gonna want to do the following. You do MPM configure like I've shown you guys before, and this gives us our base setup. For the base setup, all you need to do is remove this box because we're not going to be using the box container, and we are basically going to be inputting everything here. The only thing that you want to have in mind is making sure that this is continuous, so because we want to emit every single frame. Now the base is we have a collider, we know how to set up MPM, we want to set up the emissions, right? And then for the emissions, we have 3 kinds of emissions. We're gonna have our base emission, which is this one. We're gonna have our second emission, which is just a chocolate thing like this. This is gonna be the goo chocolate on the top, and then we have the chips as well. So real quick, this is a box. Then on the box, I rotated the box so that it would be sort of looking like this. I just basically rotated it randomly, but I was thinking that if we get the front like that, then once we start to rotate it, it gives us an interesting result. Now you want to have in mind that like you could do this in different sort of shapes, and that's gonna give the soft serve different looks, of course. Now this is just for rotation. I placed a $F with ×1 here. We do ×2, it's gonna rotate faster, but I just want to have a ×1 rotation. The next thing that you want to do is this transform here, which moves it away from the center, like right here. So the closest that we have it, the smaller circumference the rotation is gonna create, and I'll show you guys that closer here. In this transform, I am also doing a rotation, and you can see that it's basically rotating on the axis. But if we increase what we were looking at earlier here, then of course it's going to go on a larger sort of surface. So I wanted to have it close so that yeah, so that when the liquid flows, it falls on top of each other. Last, this is animating it upwards. So same technique, $F right here, and that's going to animate it up. Now, without looking at the other stuff, I'm going to delete them for now. Let me show you guys what the MPM source is doing. So on the MPM source, I have the emission type to continuous. That's going to emit every single frame. And then I started playing with my viscosity attribute. Let's have a look at what we have. So off the bat, with the following stiffness and viscosity, we're gonna get something that looks like this. And you can see that it's heavily dependent on the original shape that I created, which is this box. If you wanted to make this super close, you could literally just create a star shape or any shape that you want the outer base to look like. But as you can see, we're already off the bat getting some pretty decent results with the following density, stiffness, and viscosity like I have here. Now you will notice that on my material, I've set the material to mud and the behavior to viscous. Obviously this is not mud, but I found that it gives me some pretty interesting results. Now this right here is the chocolate on the top. And for the chocolate on the top, all I did was just put down a transform, and I started placing it basically right on top of my initial emitter. Then I also added a rotation to it so that it's rotating around like that. And then this here is grabbing my transform number 5, which is this one. So I did right click, copy, create reference copy, so that any changes that I do here are also going to be done onto this emitter. And the reason is because it's almost like parenting it. I wanted it to be like on the top. Then we have an MPM source that is set to honey, and it has much slower viscosity. And I'm creating a color so that I can identify it, and then a point group so that we can isolate it post simulation. Now once we look at these two together and we run the simulation, you will notice that something that before it used to be pretty tedious to create, it's actually quite simple to make now. Look at that. And then of course, guys, you can play with the viscosity values to give you different sorts of results on the way that this thing pours. But yeah, you want to make sure if you're setting it from scratch, all you need to do is duplicate the MPM source, because it already has the MPM container, which is this one, selected. We connect it here, and then we make this honey, and then we reduce the viscosity, run the simulation, and you see that it will work as expected. Now the last thing is our chips. So for our chips, I started off grabbing our emitter here and scattering points to this. So we have these points that are moving and changing every single frame, and then I'm giving them a random color. After that, I am copying this sphere onto them, and then you can see that they move, and you can go as far as doing an attribute randomize here to randomize the p-scale if we wanted to take it this a little further. Now we're gonna get different size little pebbles. That is connected into the MPM source, and I'm setting it to concrete with chunkiness to it, and that does exactly what that's supposed to do, which is makes this pretty stiff pretty stiff, chunky pieces. I'm gonna run the simulation and I'll be right back. Alright guys, so once we cache this, you will see that we're gonna get something that looks like this. And the next thing that we want to do is mesh this. So let me connect my cache right here, and we have a delete so that we can delete everything, isolate each one of the emitters. You have one right here, the second one, and the third. And then what I'm doing is I'm doing a particle fluid surface, and I'm sourcing the resolution. So if you increase the, if you copy and then paste relative reference here, paste relative reference, then whatever you change here is gonna change this one as well. That way we have the same point count. And I increased the smoothing so that I could get like a smoother surface on the ice cream. Then here I didn't really change my filtering, I left it as is, and this is default. And then last, for the concrete pieces, I did a VDV from particles, then I smoothed them a little bit, and then I converted them to polygons, and that gives me this. Once we merge all of this stuff together, just for preview sake, we end up with some very interesting, very controllable mixing of simulations. Thank you guys for watching, and I will be back with more.